Welcome back to Topic 3 for Algebra 1, Solve Linear Equations. In Part 1, we're going to learn how to solve both one-step and two-step equations. For solving linear equations, our goal is to first isolate the variable. In other words, we want to figure out what x equals, or any other variable. A variable is just an unknown value. So in order to do this, we need to use inverse operations. The inverse of addition is subtraction, and the inverse of multiplication is division, and vice versa. So for example, the inverse of subtraction is addition, and the inverse of division is multiplication. Let's start with solving one-step equations. In our first example here, we have n minus 8 equals negative 3. So the unknown that we want to solve for is we want to figure out what n equals. Well, we have n minus 8 on the left-hand side. Since we see subtraction, n minus 8, we need to use the inverse. The inverse of subtraction is addition. So we're going to add 8 to both sides. Because what we do to one side, we have to do the other. So keeping that property of equality in mind. Now, if we think about this and simplifying both sides, negative 8 plus positive 8 adds to 0. Or it just cancels out. But remember, when you're thinking about adding inverses, they're adding to 0. So on the left-hand side, we're just left with n. On the right-hand side, we have negative 3 plus 8, which gives us 5. Now we can check this by plugging back into our original equation to make sure that our equation is balanced. So wherever we see a n, we're going to now plug in a 5. So 5 minus 8 should give us negative 3. If we simplify the left-hand side, 5 minus 8 is negative 3, and negative 3 equals negative 3. So we're all set. Moving on to number 2. We have negative 2m equals 24, and we want to solve for m. Since this is negative 2m, what's really in between this negative 2 and m is multiplication. Sometimes when we're dealing with multiplication, we might not see the operation. It might not be as explicit as using a multiplication sign. Since we're dealing with algebra, oftentimes we don't see a multiplication x anymore. We see either a multiplication dot or really parentheses or sometimes nothing at all. And that's because with algebra, we're dealing with variables. So the multiplication x could be confused with the variable x, which is oftentimes why it's omitted and instead used other symbols in its place. So anyway, we have negative 2 times m equals 24. Since we have multiplication here, the inverse of multiplication is division. So we're going to divide both sides by negative 2 so we can get our m alone. On the left-hand side, we have negative 2m divided by negative 2. Now here it cancels, but this means it doesn't give us 0. If we actually have negative 2 divided by negative 2, that simplifies to 1, or in this case, 1m. But since 1 is a humble number, sometimes we don't always write it. Usually we just leave it in terms of the variable. On the right-hand side, we have 24 divided by negative 2, which gives us negative 12. So in other words, m equals negative 12. Now if we wanted to check our answer, we can plug negative 12 in for m in the original equation. So we have negative 2 times negative 12 should give us positive 24. Now since we have a positive a negative times a negative, that gives us a positive. So 24 equals 24. Moving on to number 3, we have x divided by 5 equals negative 7. Again, the variable that we want to solve for is x. And since we see division here, x divided by 5, we want to use the inverse of that, which is multiplication. So we're going to multiply both sides by 5. And what I do to one side, I have to do to the other side. Now this is really 5 over 1. This is the reciprocal of 1 over 5. So when we're either adding, subtracting, or multiplying or dividing with the inverses, they will cancel out. So here we have a 5 in the numerator and a 5 in the denominator. Now if we see 5 divided by 5, that simplifies to 1. So they will cancel and we'll just be left with 1 times x. On the right-hand side, we have negative 7 times 5, which gives us negative 35. So our final answer is x equals negative 35. Now we can check, plug it back in. Negative 35 divided by 5 should give us negative 7. If we simplify the left-hand side, we will get negative 7, and negative 7 equals negative 7. So we are all set. Our last problem here, we have 2/3 times y equals 20. So here we have 2/3 as a fraction. Now this is really being multiplied by y. So the inverse of multiplication is division. Now I can divide both sides by 2/3. But when we divide by a fraction, that's actually the same thing as multiplying by a reciprocal. So dividing by a fraction equals multiplying by the reciprocal. So don't ask why, just flip and multiply. So instead of dividing on both sides now, the reciprocal of 2/3 is 3/2. So I'm going to multiply both sides by 3/2. Again, we want to preserve that property of equality. On the left-hand side, we have a 3 in the numerator and a 3 in the denominator, so that reduces to 1. And a 2 in the numerator and a 2 in the denominator. That also reduces to 1. So we're just left with y on the left-hand side after we multiplied by that reciprocal. On the right-hand side, we have 20 times 3/2. Now this is really 20 over 1. So when multiplying fractions, we're going to multiply straight across. 20 times 3 gives us 60. And 1 times 2 gives us 2. So we get 60 divided by 2, which reduces to 30. So y equals 30. Now we can check our answer by plugging back in. 2/3 times 30, which we're plugging in for y, should give us 20. Now again, this is really 30 over 1. So if we simplify it, 2 times 30 is 60. 3 times 1 is 3. 60 divided by 3 is 20. And there we have it. Now let's move on to two-step equations. Now there are a few steps that I like to use when simplifying two-step equations and solving for that unknown variable. Something that's optional, but I really recommend doing, is drawing a line vertically through the equal sign to separate the right side from the left side. This really provides a visual if you want to keep in mind those properties of equality. Then what we want to do first is we want to undo addition or subtraction, whatever you see, with the inverse. Then we would move on to undo multiplication or division with the inverse. Then, just like we did before, we're going to have a check step where we plug our variable back in to check our work. Let's try some examples. Our first example here, we have 6m minus 8 equals 16. So what I'm first going to do is just draw a line vertically through this equal sign to make sure I'm separating the left-hand side from the right-hand side. Then, according to my steps, I want to undo either addition or subtraction first with the inverse, whatever I see. Since I see 6m minus 8, I really want to focus on this subtraction here, the minus 8. Now the inverse of subtraction is addition, so instead of subtracting 8, I'm going to add 8 to both sides. Now I'm going to simplify. Negative 8 plus 8 adds to 0, so it cancels out, and I'm going to bring down this 6m. On the right-hand side, we have 16 plus 8, which gives me 24. The next step that we want to do is undo multiplication or division with the inverse. Since I see 6 times m, remember there's really a multiplication dot that's like hidden right here. The inverse of multiplication is division. So because I want to solve for my variable, I'm going to divide both sides by that coefficient, that number that's clinging on to dear life. So I'm going to divide both sides by 6. 6 divided by 6 is 1, or 1m. Remember, 1 is a humble number, so sometimes we don't always write it. And on the right-hand side, 24 divided by 6, remember this is a fraction, but it still means division, gives us 4. Now we can check our work. Plugging back in, we have 6 times 4 minus 8 equals 16. And when we're simplifying this, I want us to go in PEMDAS order in order to simplify this expression. So we'll start with our multiplication. 6 times 4 gives us 24, minus 8 should equal 16. On the left-hand side, 24 minus 8 is 16. 16 equals 16, so we're all set. Next example here, we have 6x minus 8 equals 22. So I'm going to draw this line vertically here. Since we see subtraction, minus 8, we're going to deal with that first. We can also think about it kind of as like a third wheel in a relationship, is how I like to explain it to my students. Really, the x is what we're going for. So we need to get rid of that third wheel first, the one that's kind of just clinging to the outside, which is our negative 8. We can do that by using the inverse. So instead of minus 8, we're going to add 8 to both sides and simplify. Negative 8 plus 8 adds to 0, and 22 plus 8 gives us 30. Now we can bring down our 6x, so 6x equals 30. Now we still want to get x alone. X is a loner. So we have this stage 5, but really actually stage 6, clinger here with 6 times x. So since this is multiplication, we need to undo it with division. So we're going to divide both sides by 6. On the left-hand side, it reduces to 1, so we're just left with 1x, or just x. And on the right-hand side, we have 30 divided by 6, which gives us 5. Kind of got shifted over here, but. Now to check our work, we're going to plug it in. So we'll have 6 times 5 minus 8 should give us 22. Again, we want to plug it back into the original equation. O is the original. Thinking about PEMDAS, we'll deal with multiplication first. 6 times 5 gives us 30. 30 minus 8 should give us 22. 30 minus 8 does give us 22, which matches the right-hand side, so we are all set. Moving on to number 3, we have k divided by negative 3 plus 3 equals 2. So we're going to draw that vertical line. Now the third wheel in this relationship is at positive 3 hanging on the outside. So since we see addition, the inverse is subtraction. We're going to subtract 3 from both sides. 3 minus 3 adds to 0. 2 minus 3 is negative 1. So now we're left with k divided by negative 3 equals negative 1. Now on the left-hand side, this is k divided by negative 3. The inverse of division is multiplication. So we're going to multiply by the reciprocal. We're going to multiply both sides by the number that's in this denominator here, since we want to isolate that variable. So we're going to multiply both sides by negative 3. And remember, this is really negative 3 over 1. Multiplying and simplifying, we have a negative 3 in the numerator and a negative 3 in the denominator. So we'll really just end up with k over 1, or k after we simplify. On the right-hand side, we have negative 1 times negative 3 over 1. A negative times a negative gives us a positive. So k equals 3. Now let's plug it back in to check. 3 goes in for k, divided by negative 3 plus 3 should equal 2. 3 divided by negative 3 is negative 1, plus 3 equals 2, and 2 does equal 2. So we're all set there. Okay, final problem. We can do this. 1/3 x plus 3 equals negative 2. So we're going to start by drawing our vertical line here. Again, what we see for that third wheel is that positive 3. The inverse of addition is subtraction. So we're going to subtract 3 from both sides. 3 minus 3 adds to 0. Negative 2 minus 3. So again, we have two signs. So we are going to, when we see two of the same signs, we're going to add these numbers and carry down that sign. So negative 2, and we're going backwards to the left on the number line. 3 spaces gets us to negative 5. On the left-hand side, we have 1/3 x equals negative 5. Now, because this is multiplication here, we could divide both sides by 1/3, but remember what we learned earlier in this video is that when we divide by a fraction, it's the same thing as multiplying by its reciprocal. So the reciprocal of 1/3 is really 3 over 1. We flip it. So I'm going to multiply both sides by 3 over 1. On the left-hand side, we have a 3 in the numerator and a 3 in the denominator, a 1 in the numerator and a 1 in the denominator, so we'll just be left with x equals. On the right-hand side, we have negative 5 times 3 over 1, which gives us negative 15. Now we can plug it in to see if it works. 1/3 times negative 15 for x plus 3 should give us negative 2. 1/3 times negative 15 is negative 5, plus 3 should give us negative 2. If we start at negative 5 on our number line and go 3 steps to the right, we'd end at negative 2. So we are all set. That was topic 3 for Algebra 1, solving linear equations, specifically one-step and two-step equations. Thank you for watching.